Okay, sorry I'm not there today. My son woke up sick, and as you can see, my flip chart didn't print correctly. Trying to do this on my iPad, so I'm going to jump down here to where it says we're going to use the first derivative to determine where the function is increasing or decreasing. So to do that, we're going to use the first derivative. So remember that the first derivative, the original function's increasing or decreasing when the first derivative changes. I'm sorry, the original function's increasing when the first derivative is positive and decreasing when the first derivative is negative, because that's our slopes. So here's what we're going to do for every problem. We're going to find where the first derivative is 0, because that's a horizontal tangent. Then we're going to make a chart to decide if the first derivative is positive or negative, to know if the function's then increasing or decreasing. Because if we go increasing and then decreasing, we have a max. If we go decreasing and then increasing, we have a min. So we're going to jump forward and do a problem. We'll do number 2 down here on the next page, but first let's discuss all of this up here. So the first derivative is undefined if there's no horizontal tangent to the graph. So that means either it's a vertical or there is no tangent at all. For example, we don't have a derivative when you have a sharp point. So for example, the absolute value of x is a v, so there's no derivative, or it's undefined. The derivative's undefined at 0. So the first derivative test that we're going to do when we get down here to problem number 2 won't work if it's a problem like the absolute value of x where you have a sharp point. So most of the problems we're going to do are going to be polynomials so that we have nice curves. Remember I said yesterday, critical points are either maxes or mins. So for a graph like this one, we have a minimum, so that's 1 critical point. For a graph like this one, which is x cubed, there is no maximum or minimum, so there is no critical points. And then a graph like this, which is the sine of x, we have a max and then a min and then a max and then a min. So there's infinite critical points through that whole graph. This is kind of what I just drew on the page before, that if we have a decreasing changing to increasing, we have a minimum because it goes down and then up. If we are increasing then to decreasing, that's a max because we were going up and then down. So we're going to use the first derivative being negative or positive to help us decide if we have a min or a max. So for number 2, we want to identify the max and the mins. So the first step is always find your first derivative. So we're going to use our power rule. Then we're going to set our first derivative equal to 0 because we want to find the critical values, which is when the first derivative equals 0. So now, which is really nice, all of these terms divide by 3. So it's going to make our factoring easier. So now what multiplies to negative 16, that adds to negative 6, we're going to have negative 8 and positive 2. Set each factor equal to 0. And our critical values are 8 and negative 2. So here's what we're going to do with those two values. I'm going to make a chart. Now on your quiz on Monday, I'm going to provide you with a chart, just like for the next problem we're going to do. So we have negative 2 and 8. And if I put my intervals in here from negative infinity to negative 2, negative 2 to 8, and then 8 to infinity, And what we want to test is the first derivative. So I actually need another row on my chart. Sorry about that. So I want to know if the first derivative is positive or negative, then it's going to tell me about the original function f. So we can pick a number, any number less than -2, and I'm going to go with -10. You could have picked -3, you could pick whatever number you want that's less than -2. And what I'm going to do with the -2 is I'm going to plug that back into my factored form here to see if I get a positive or negative value. I don't care what the actual value is, I just care if it's positive or negative. So -10 minus 8 is negative, and negative would be here, -10 plus 2. So a negative times a negative is positive. Now I'm going to pick a number between -2 and 8, so let's pick 0. So when I plug in 0, I can actually probably more easily do that into the non-factored form. So 0 minus 16 is negative. And then lastly, I'm going to pick a number more than 8. Let's pick 10. And when I plug 10 into the factored form, I get a positive times a positive, which makes a positive. Therefore, because the first derivative is positive on this first interval, the original function is increasing. Same with this interval on the far right. Now in the middle, it's decreasing. So I'm a very visual learner, increasing to decreasing, so that means at -2 we have a max, and decreasing to increasing, at 8 we have a min. But we want to find the coordinates of those points, so -2 comma something and 8 comma something. So to find the values of these y's, we're going to use the original function back up here, f of x, and plug in -2 and 8. So now here's one caution. Your first derivative doesn't have to change signs from positive to negative or negative to positive to have a critical point. Because remember, a critical point is where the first derivative equals 0. So here when I have x to the third, my first derivative is going to equal 0. It's going to be horizontal right at the origin. But if I look at the derivative, which is 3x squared, I get a parabola. This side is positive and this side is positive, meaning the whole graph, the original graph, is always increasing. So it's a critical point, but it's not necessarily a max or a min. So now we're expanding our definition of critical point. Okay, so this is the problem here. This is how it's going to be set up on your quiz on Monday. So the first step, let's find the first derivative. We're going to use the power rule. We're going to set it equal to 0. And when I factor, I'm going to factor out the -3, but you can't divide it to the other side because I'm going to need that -3 when I'm testing the signs. So now, to factor, what multiplies to 3 that adds to -4 is going to be -1 and -3. So when I solve this, I get x equals 1 and 3. So those are my critical values. And then I need my intervals, -infinity to 1, 1 to 3, 3 to infinity. And then the numbers that I'm going to test, something less than 1, between 1 and 3, and more than 3. So when I plug in 0 to the derivative, I get a -3 I'm actually going to do it in the non-factor. So negative 3, and this is going to be positive because 0 minus 0 plus 3 is positive. So that's going to give me a negative value. When we plug in 2, I'm going to plug in 2 to the factored form, so that's negative times positive times negative, which negative times negative is a positive. And then lastly, when we plug in 5, it's going to be negative 3 times positive, which is negative. So here we have decreasing, increasing, decreasing. Because I wrote my intervals in red, I now have my answers to E and F. We're increasing from 1 to 3, and we're decreasing from negative infinity to 1, and 3 to infinity. But now I need to know my maxes or mins. Because this is going decreasing to increasing, that is a min at 1. And increasing to decreasing, that's a max. But now I need these y values. So what I'm going to do is plug in 3 to the original, plug in 1 to the original. So when I plug in 1, we get negative 5. And when I plug in 3, I get negative 1. Okay, so your homework page in your packet did not copy very nicely. And I have a text message set up to go out to you this afternoon with this nicer image. So if you can't read it, we can pause the problem here for you to be able to see numbers 1 and 3 nicely. Numbers 4 through 9 you can read okay on your paper, definitely not here on my video. These got all messed up. With my font. So we'll pause it here so you can see 1 and 3 and start your homework now in class.